Section 5.6, graphing linear inequalities in two variables. So this looks a lot different than the systems of equations we had done before, but the reason that we're doing this is because it's actually going to lead us into a system of linear inequalities, and so that's how it's connected to the unit. That will be in the next section. So with linear inequalities in two variables, it would look like this. It has an inequality symbol, either greater than or equal to, less than or equal to, greater than or less than, and it can look like the equation of a line other than that symbol. You know, that looks like y equals mx plus b. So anyways, when we look at this, in order to graph that inequality, we actually just graph that line, the y equals mx plus b. This is y equals 3x plus 3. Connected to this here, something called the boundary line. And then you'll notice that part of the coordinate grid has been shaded. It's dark over on the left side here. And that actually means that every point to the left, including these two highlighted points, negative 4, 4, and negative 4, negative 2, would make this inequality true. If we plugged those values in, it would make a true inequality. In fact, and we'll talk more about how we know this will happen, this point that's on the line, 0, 3, will also make this true. If you plug in 0 for x and 3 for y, you get 3 is greater than or equal to 3, which is true because it's equal. However, if you plugged in this point's coordinates, which would be 4, 6, 4 for x, 6 for y, you'd actually get an inequality that's not true. And that's how we're going to know that we don't have shading over here. We don't shade or color in this side like we do on the left. So we'll talk more about how we know how to do that, but this is what it will ultimately look like. You're going to have a line, and you're going to have one side of that line shaded. You might have picked a couple of points to look at in order to figure out where to shade. All right, let's try it out. So, in order to graph a linear inequality in two variables, we're going to follow three simple steps. First, I'm going to use graph the boundary line for the inequality. We use a dashed line anytime we have a less than or greater than, and a solid line anytime we have less than or equal to or greater than or equal to. So you can see I have my original inequality. Y is less than 2x plus 1. It's in basically slope-intercept form. I'm going to graph the line y equals 2x plus 1. Y-intercept of 1, slope of 2, up 2 over right 1, 2 over right 1, or down 2, left 1, and I'd have my boundary line. Now it's a dashed line anytime I have a less than or a greater than, which is what I have here now. It's just like when we did inequalities before, and these symbols, the less than or greater than, had open circles. These symbols, the or equal to's, had filled in circles. Think about the dotted line as a whole bunch of open circles next to each other. They're not filled in completely. Step 2 is to test a point that is not on the boundary line. So we get all of these possibilities or all of these possibilities. And so I've chosen the point 3, 4. I'm going to test that by plugging into my inequality. Now again, 3 is my x, 4 is my y. So 4 in for y, 3 in for x, and I just want to see if this is true. That's going to tell me that 4 is less than 6 plus 1, and that 4 is less than 7. And let me just clear that up a little bit there. Make that a clear one. And is 4 less than 7? Yes, it certainly is, which means that I have identified a solution. So 3, 4 is a solution. That's a good point. But that means that everything over here, everything to the right, is actually going to be a solution as well. So what I'm going to do is I'm going to shade that entire side. So at this point, just do your best with your pen or pencil. Pencil's definitely a better option, or colored pencil, to try to shade in as much of that side as possible. Now, if 3, 4 had not worked, or if maybe we had picked a point over here, such as negative 2, 0, and we plug it in, we're going to see what would happen. I'm going to look at that point, negative 2, 0 there. When I go to plug that in, I'm going to get, oops, wrong color there. Sorry about that, guys. I'm going to get 0 is less than 2 times negative 2 plus 1. I'm going to just check that. 0 is less than negative 4 plus 1. 0 is less than negative 3. And that is obviously not true. 0 is not less than negative 3. That's not an x. That's saying that it's wrong. And so that means that since this is not a solution, nothing on this side is going to be a solution. So that's why I'm going to shade over here. Every single point over here is a solution to the inequality. It's just like drawing an arrow on a regular inequality on a number line. Just a whole bunch of arrows going this way, this way, this way, this way, this way. They're all covered up, and now it's completely shaded. So that's how you do it. There are times that it seems like we actually don't have enough information. Sometimes one of the variables is missing. That doesn't mean we can't do it. If we know that we're supposed to be doing this in a linear inequality in 2 variables, we have to know how to graph it. So let's say our problem is x is less than or equal to 3. Well, we remember that the line x equals 3 is just a vertical line that goes through the point 3, 0. It's every point in the coordinate grid where x is 3. So it's all the way up and all the way down. Now, because I have less than or equal to, I'm going to use a solid line. That's what I want to use there. So at this point, I now want to pick a test point, and if possible, I always want to pick the most convenient test point that there is, which is 0, 0, and I'm going to plug that in. Now, when I test 0, 0, it's a little tricky because I don't have anywhere to plug in that second 0. I don't have a y to plug in, so I just plug in the first one, which is 0 for x, and I get 0 is less than or equal to 3. Now that statement is true, which means that 0, 0 is a solution. So I'm going to want to shade the side of the coordinate grid that has 0, 0 on that side of the line. So let's just do that real quick. We'll get a nice big thing here, and it doesn't have to be perfect. I mean, you're just trying to give an indication here. This is making it very clear, where it is. And so we use that test point of 0, 0, and everything to the left of that line, and actually everything including the line, because it's solid, is going to be a solution. We'll do the same type of thing for the next problem. Y is less than negative 1 is a horizontal line. If I look at it as y equals negative 1, goes to the point 0, negative 1. And because it's just a less than, I want to have a dotted line. The points on that line will not satisfy the equation, so I don't want to use that. Again, I can pick whatever test value I want, so I'm going to test 0, 0 since it's not on the line. If it is on the line, then I just pick another easy point, like 1, 1 or 1, 2, something like that. And just like before, I don't have everything that I can plug in here. I don't have an x to be plugged in, so I'm just going to plug in the 0 for y and get 0 is less than -1, and that is actually false. So because that's false, I know that my solutions are not on the same side of the line as the 0, 0. So I'm going to shade everywhere else. I'm going to shade down here. And again, you're just trying to do your best here. It doesn't need to be perfect. You're just trying to indicate that this is the case. Some people just even put like kind of dash marks or trying to show it if they don't want to color it in with a pencil too much. I would really advise you not to use pen here, because if you make a mistake, that's a lot to fix. But that's how you do it. That's how you do it if there's one variable missing. So let's just take a look at this here. We have a word problem. We can use a linear inequality to solve it. You have $12 left on your iTunes account, and you limit your options to $3 apps and $2 songs. We want to write and graph an inequality that represents the number of apps and the number of songs you can download. First thing we need to do is define variables. So let's just use X and Y to represent apps and songs. So now we need to write our inequality. We know that each app costs $3, so we could say that 3x is going to be the amount of money we'll spend on apps, and 2y, very similarly, would be the number of the amount that we spend on songs. Now we're going to add those two values together, and we can't spend over $12. We could spend less than or equal to $12, though. That would be okay. So now we want to go ahead and graph this. I think it's probably going to be easiest to put this in slope-intercept form. I'm going to start by subtracting 3x. So I'm going to have 2y is less than or equal to negative 3x plus 12. And now I'm going to divide everything by 2. So I have y is less than or equal to negative 3 over 2x plus 6. So that's in slope-intercept form. I'm going to go ahead and graph this, and then that's going to, we're going to be able to see where we'll shade from there. All right, so you can see here that we've graphed our line. We went to a y-intercept of 6, and then we had a slope of negative 3 over 2, so we went down 3, right 2, down 3, right 2, and we generated our line there. Now what we need to do is we need to pick a test point, easiest one to pick, because we had our original inequality is what we actually want to plug into, but we're going to pick the test value of 0, 0. That's going to be the easiest one. So in my original inequality, that's 3 times 0 plus 2 times 0 is less than or equal to 12. And that's actually pretty obvious. It should be really clear that we would be allowed to buy 0 apps and 0 songs. We don't need to pay for anything. We could just say, keep the $12 in the account. We just can't spend too much. So it makes a lot of sense that we actually would be looking down below here. And so where I want to shade is below this line and to the left. But realistically, when I do that, I go like this here. I can kind of shade it, kind of lazy that way. I really have to think about the fact that I'm talking about songs and apps. I can't order anything that's negative there. And so I also can't order anything that's less than, that's a fraction. So even though I've shaded everything, I actually only have a limited number of real options. I could actually just hit anything that's on this grid right here. You can see I'm trying to make sure I cover everything. These actually are all of my realistic options. I have to be in the shaded region or on the line because it's solid. But I have to make sure that I'm not negative with either value because that doesn't make any sense. And I also can't order half of a song. So if I was to pick one of these, such as this value right here, that would mean purchasing 2 apps and 2 songs at the 0.22. I'd have some money left over because I'm not right on the line, but that's a possibility. If I ordered 2 apps and 3 songs, that would cost exactly $12. Same thing for 4 apps and no songs. I could order just 1 app and nothing else. Those are all possibilities. This is a matter of being discrete, and that's where it comes into play there. So I hope this makes a lot of sense, and now that you feel a lot more comfortable. Nice job.